Okay, I'm going to only talk about I'm going to talk about our journey to START first, and I'm going to then talk about how the START project is advancing the structural biology. So I'm not going to talk about the material side of the START program. We started off, well, let me just initially say that I believe it's completely essential that Africans participate in the global challenges of structural biology and protein structure determination, macromolecular structure determination, biological structure determination at every level of resolution. And we need to do this because of acquiring fundamental knowledge and making applied discoveries, but we also have a number of unique problems with respect to disease burden, food security, and bioeconomy that structural biology can definitely contribute to. And I'm also going to talk about the convergence of macromolecular crystallography and cryo-EM, which is happening now. And in fact, most of the synchrotrons are now introducing cryo-EM facilities on their sites. So the first one to do this was, in fact, the diamond light source. And there you can see the Cryo electron microscope in the storage ring and on the floor, which turned out to be amazingly stable, and the performance of the microscope is spectacular. So this is the kind of thing that you can get out of this kind of microscope. It's in every respect, I'll return to this later on in the talk, but in every respect, you can get the same quality of information as you can get out of X-ray crystallography. And in fact, we were quite early adopters of this technology. And you can see one of my students, Andani Mulelu, we were working in Frankfurt at the time and collecting data on the Cryo electron microscope in Frankfurt. So one thing that's terribly important to realize is that the whole business of doing protein structures involves a pipeline which starts off with sample selection, requires you to make soluble expression of a particular protein, purify that protein, crystallize the protein if you're going to go to crystallography, or not if you're going to electron microscopy, a data collection step, data processing step, an interpretation step, and obviously a publication step. But the bit that happens on the synchrotron is this data collection step. And with modern synchrotrons, this takes less than a second per crystal. And so the emphasis on this in terms of the total process, which can take more than 1 year, is that the actual synchrotron activity takes place in a very short time. So when we started on doing this in the last century, we got involved with the synchrotron at ESRF, and there's another one of my students, Sarah Kamani, working at ESRF, and the problem that we faced was that there was no existing community in Africa or South Africa that was involved in this kind of work. So basically, my students, in fact, led by a Zimbabwean, Itai Chapati, was a leader in actually accessing synchrotron facilities. And I was quite skeptical at the time. And he said, well, let's just put in an application and see what happens. And this led to a very long-term relationship with the EMBL, which enabled us to sign an MOU and get on with using the ESRF synchrotron. Well, I should actually go back in time to the beginning of what happened to structural biologists in South Africa. And the solution that Aaron Klug found was to go abroad. So he just left South Africa, went and worked in the UK, obviously won his Nobel Prize, invented the whole business of 3D reconstruction by electron microscopy. And the impact that he had on the local scene was non-existent. In fact, it made problems worse because there was no incentive for people here to actually join in this branch of science. What Ed Sturrock and I eventually did was we collaborated with people abroad, and we actually published the first two structures in 2003, one by electron microscopy and one by X-ray crystallography. And then I tried to go from that platform to try and establish everything in South Africa. And we were supported by the Carnegie Corporation of New York to actually build this master's program in structural biology. And it turned out to be amazingly successful, and in particular produced 17 MSc graduate and 3 honors graduates in structural biology. I will say that at the present time, which is 11 years later, only one of these graduates has actually found a job in science in South Africa, and that's Jeremy Woodward, who's currently working in Cape Town. Another big important thing that happened in structural biology in South Africa was the recruitment by the University of Western Cape of Wolf-Dieter Schubert. And he came with a group of students from Germany, and they started working at University of Western Cape with great enthusiasm. Unfortunately, the whole subject of structural biology was unsustainable at University of Western Cape. And then he's now moved to Pretoria, and he's reset up everything in Pretoria from scratch, which has been very hard for him. And indeed, it was made a lot easier by the START program. The other person that was extremely important in the history of structural biology is Heinrich Dürr, who worked at the University of Witwatersrand and became the Saatchi chair in protein chemistry and structural biology. And his lab is surviving and thriving. And at the moment, they have a very strong group of structural biologists that Emmanuel already referred to. And they're prospering. The other group that started is the group of Dirk Opperman in the University of Free State. And in fact, he inherited quite a lot of the apparatus that we built up under the Carnegie program, and that enabled him to get started. And he's also built up a very exciting and useful group. So what we did in the early days was to use the Synchrotron facility at ESRF. And there's a picture of ESRF, that's me working at BM14. And in fact, we did it through a memorandum of understanding with the EMBL. So it wasn't in any way a subscription to ESRF. It was simply an agreement that we as a group had with the EMBL. And this resulted in quite a lot of work that was pretty good, and all got published. And okay, but unfortunately, at the end of 2009, in spite of the success of the program, decisions were made to halt the program. And I was really worried about the sustainability of the discipline of structural biology in South Africa. And indeed, the University of Cape Town then reorganized and allowed me eventually to rebuild the thing in what then became the Aaron Klug Center for Imaging and Analysis. And we built a facility in which we did the structural biology, but the whole thing was that it was also supposed to cater for all disciplines, including the structural biology. So it's shown in this green bit on the left-hand side here as the 600 square meters of the Aaron Klug Center. There it is. And what I tried to set up in the Aaron Klug Center was the entire pipeline to do the protein crystallography, from chromatography, crystal trials, selection of crystals, and initial data collection prior to sending things to the synchrotron. We also set up a structural biology research unit led by Jeremy Woodward, and that was to promote structural biology at the university and to formulate and pose questions in structural terms. And that's been remarkably successful. The university allocated 80 square meters of lab space to this activity, and we've managed to keep it going. It's still going at this time. Yeah. So we held a number of events during this time, including the first African Structural Biology Conference in 2006. We held the Structural Biology and the Bioeconomy meeting in 2012, which was organized by funded by the German Ministry of Education and Research and the Helmholtz Center. We held a Biophysical Society sponsored meeting called Biophysics and the Understanding and Diagnosis and Treatment of Infectious Diseases in 2014. But we never really overcame the major problems. And the problems are lack of infrastructure for educating people in the discipline, infrastructure for preparing proteins and characterizing proteins, infrastructure for determining structures, and infrastructure for doing big data and computation. The final 1E is a big problem nowadays because the whole business of 3D reconstruction by electron microscopy depends on huge computing infrastructure, which we've recently acquired through a connection set up with NVIDIA by Lawrence Norris. And we were able to purchase a cluster of very powerful GPUs, which were not actually allowed to leave the United States. So they are sitting in Cape Town now, and we're using them. So we also have difficulties in obtaining sustainable funding for early career positions, for students, for projects, and for equipment. And I'm going to comment that our national science infrastructure is not really conducive to the development of new science. There's a lack of transparency and a failure to engage with the scientists and very poor planning. And from our point of view, from the international people looking in, we really do have a lack of credibility in our whole structure. But nevertheless, in spite of all of this, the START program, which is funded by the GCRF through the Science and Technology Facilities Council, that's the same body that funds Diamond, created a UK-Africa partnership to develop world-class research in energy materials and protein structure determination. And the grant funded essentially training in synchrotron techniques based at Diamond Light Source. And it funded also researchers who studied emerging and neglected diseases of direct importance to the African continent. So it was a remarkable grant. And in fact, the initial 9 investigators came from 7 institutions. You can see their names there. And that was the beginning of the real establishment of structural biology in South Africa, I would say. What was funded for 3 years was 9 research assistants, postdocs, including a research budget and travel costs, a local resource center in Cape Town, 2 posts at the research center, annual workshops in South Africa, annual meetings in South Africa, travel between Diamond and South Africa for both South African and British participants. And the tragedy that struck with the COVID-19 pandemic meant that all this virtually came to an end in 2020. And basically we have 1 year's budget, which has almost not been spent. The people that we recruited as postdocs include the list of people here in University of Northwest, University of Witwatersrand, University of Cape Town, NICD, University of Free State, and University of Stellenbosch. And all of those people have actually, at this stage, done crystal structures, prepared proteins, done the whole process, been through the entire pipeline. We've also been encouraged by the people at Diamond to extend the program to many other centers, including Paul Capo at the University of Zululand. Unfortunately, things have folded at Zululand, and he's now moved to University of Johannesburg. And Kevin Naidu at Cape Town, Anwar Jardine at Cape Town, Brandon Weaver, who's now unfortunately left, Penny Moore at NICD, Nigel McCoy, who's now moved to UFS, and Portia Mamela, who's moved to Rhodes University. So there is, if we were given the opportunity to have a further START program, all of these people would then be involved, and you'd see that the growth of structural biology in South Africa would happen significantly. The workshops that we actually succeeded in holding was this biophysics and structural biology at Synchrotrons, which was held in 2019. You can see how much, am I nearly finished, Simon?
Yeah, you should wrap up.
Okay, that's fine. Those are the people that went. And then we held another Cryo-EM workshop at the end of 2019. And this is, I'm just going to make this one point, and that is that Cryo-EM is developing extremely rapidly. And these are the kind of results that people are getting out. This is a paper in Nature in May this year by Carman Yip. You can see clearly defined hydrogen atoms. This is not an electron density map, it's an electric potential map of the protein. So you can actually see, as a result of the interaction of the electrons with the protein, you can see every atom very clearly, including the hydrogen atoms. So I would say that START has been an amazing success. It has been the biggest contributor to the development of structural biology in South Africa to date. We've established a mechanism to enable more people to become involved, giving people free access to the resources of the Aaron Klug Center. And the next event that we're going to have is a virtual CCP4 workshop early next year. The threat to the whole business of doing structural biology depends that South African funding remains very limited, but there has been some, and it's helped in critical areas. And the largest threat that we face is loss of members of our very small community. This means it's imperative to find sustainable funding to retain the people that we train. And I'd like to thank these people, Chris Nicklin, Gunnar Evans, and Frank van Delft and Diamond, and all the people that have been involved in the program, but these people in particular, Carmine Tolmi and Tandek, Mario Wolf-Dieter, Jeremy Woodward, and Kelly Shabali. Okay, that's all I have to say.
I really want to thank you for the scope and detail in the presentation. And I wish we could have seen more. It was lovely to listen to. I think people, please put questions to Trevor in the chat, and everyone, Tandeka Moyo, who is in his list there, will speak. I think it's Friday. And we just thank you, Trevor, and sorry, but we move on. And
okay.